In this lesson, we're going to go through how to split condensation polymer repeat units back into their respective monomers. So we have two examples today. We have one that's a polyester and another which is a polyamide. Now, if you're wondering how to join two monomers together to create a condensation polymer repeat unit, I have produced videos on that content, and the link is in the description below. So I suggest you watch that first because it's the precursor to today's lesson. The first thing you need to do is identify where the ester bond or amide bond is, and that's the place you work backwards from. So if we start with this first one with a star there, we can see immediately that we have an amide bond there, and there's the other one. What we need to do is work backwards and put the water back into the molecule, and then that will give us the two monomers that have been used to make this repeat unit. So if we look at my drawing there, this is the rule. Carboxylic acid is the C double bond O bit. So let me just write this in red underneath. It's a C double bond O OH, and the amine bit will be NHH. And if I just circle how the water is formed, it's just that bit. That's the bit you have to put back in. So that means when you find the amide bond, the OH has to go there, and the H has to go back onto the nitrogen. And then you can split the bond down the middle, which is what that dotted line is there. Which peptide bond, which amide bond do I start with? So I'm going to start with this one. I can see that I need to insert a hydrogen there and the OH onto there. And then if I look at the other side, I have to do the same thing. So there's the nitrogen there. So the hydrogen has to go back onto there, and the OH has to go back onto there. So let's see what that looks like, and then we can make sense of the result to determine the monomers. So we've got this bit. It's a C double bond O OH. So that bit there is what I've just drawn there. Then we have NHH, and then this CH2, CH2, NH2. And then on the other side, we have C double bond O OH, and then up to a C double bond O. And now, if you notice, I can also insert an OH there and a H there. So what does that give? It gives me that, and then this bit which is left, NH2. So look at the splits there. So I've got 4 bits to look at. I can see that this bit here is connecting to the next monomer. So that's that black line. And then the same goes for the one on the left-hand side here. We can see this is running off to the remainder of the polymer chain. So that bit there is that bit there. So we don't need to consider that part and that part. So what we're left with in the middle are the two monomers. We can see we have this one, which is NH2, CH2, CH2, NH2, which is diaminoethane. And then we have this one, which is ethane dioic acid. So there are the two monomers. So what I've done is I've just applied the rule. Every time I see a C double bond O, I put an OH. Every time I see an NH, I put an H, and just split it into parts and then look to see what I have left. And I'm finishing with these two, to the green ticks, this monomer and this monomer. So let's do the next one. Hopefully you can see this is an ester bond. So an ester is C double bond O at CO. And I can see that there's an ester bond there. And what looks to be would be the start of, if I was to just, what looks to be the start of another one there. So ester bonds are made in the same way as amide bonds, which is we have to put in the OH back onto the carboxylic acid to reform the carboxylic acid monomer, and then put the H back onto the alcohol, because an ester is made from an alcohol and a carboxylic acid. That's the two bits that need to go back in. So I'm going to do exactly the same as I just did a moment ago. So I can see, so I just use red there again. There's my ester bond. So I can see I'm going to put the OH back onto that carbon, and then onto that oxygen is going to be the hydrogen. And of course, in doing this, remember, this is the ester bond that's breaking. And then the H is going to go back onto there. And then this bit I've just introduced would be the OH. Let's draw and see what we have. And then that is bonded to, and then finally is this bit, which I'll just draw at the bottom, the OH which I've just introduced. That thing there is what I'm just overlaying in red, is this thing there. But we don't need to worry about that because we can see we already have our monomers. So this is monomer 1 and then this is monomer 2. And we can see they're condensing in the middle and that produces that ester bond in the middle there. Thanks for watching. See you in the next one.